Good afternoon. Today, I'm excited to speak with Rodrigo Liang, co-founder and CEO of SambaNova Systems, a company at the forefront of AI innovation. The company was co-founded by Rodrigo, Chris Ray, and Kunle Olukoton. Rodrigo has led SambaNova in revolutionizing AI infrastructure, attracting major investment, in fact over $1 billion, and partnerships along the way. We are so happy to back you 7 years ago with my partner, Lipo Tan, who has been the chairman of SambaNova. I had the privilege of watching the company's journey closely from small number of employees, now over 500. Today, I'd love to dive into your vision for AI, how SambaNova is shaping the future of AI hardware and software, and what's next for the industry. Rodrigo, welcome to the next wave.
Yeah, thank you so much, Young, and thank you for your support all these years. It's been a great journey, and certainly it's been wonderful to have you supporting us this whole time.
It's been a fun journey, right? It's love to see you growing and building the teams over time. It's been an exciting journey to see it.
Yeah, and it's been a market that's changing so dramatically, from 7 years ago when we started to now. You've got all the model players, the chip players, the system players, the cloud players, and so it's been an incredible journey so far and a lot more to come.
So for our audience, they may not know you, SambaNova. So let's set the level ground. Let's talk about, what is your background, SambaNova, what problem you're solving, and some background around the company that I think would be a great start.
Right. Yeah. Well, SambaNova, we're a spin out from research that was done at Stanford University. My co-founders, both amazing professors at Stanford, really thinking about hardware, software, and the full stack, really. And so what we've created in the last 7-8 years is a full stack company. And by that, I mean, we build our own chips on one end, chips that compete with NVIDIA on training and inference. And on the other end, we leverage open source models and we drive APIs into the market. And so what we want to do is for large enterprises, governments, sovereign players, where they want to actually deploy these types of AI capabilities, but they have privacy concerns, energy concerns, ownership, model ownership concerns, we're able to actually give them a full end-to-end solution that delivers those capabilities on-prem or in whatever secure environment they have. And that's really the drive for SambaNova, to take AI into these highly secure and private environments and deliver state-of-the-art capabilities without having to compromise the security of your data or the security of the information you're actually trying to use.
So clearly, we are in the midst of major a wave of innovation that are going on, right? We have seen the personal computer wave, we have seen the wave of cloud, internet, and then mobility, cloud, then AI is where we are today. Right. And you have started early with the founders who were leading the research in AI at Stanford.
Right.
And you have built a team, and you are building hardware, chips, software, and full stack. Right. So tell us a little bit around that, because I think most people doesn't know what full stack means, right, what the system means. So if you can articulate those, that would be great.
Right, and full stack can be full in different ways for different people. And so our pieces, we have a chip and system on the hardware side. Then we have the software stack that includes all the runtime and compiler software that allows us to actually make our systems CUDA free. We're very proud of the fact that there's no manual coding within there. And then above it are leveraging open source models that turn into APIs to run people's applications. And so those are 3 layers. And so if you think about the hardware piece, ultimately, it's about performance, power, and cost. I mean, it's the world's moving towards inference. In AI, there's training and inference. And I always say, in the world of ROI, the training is the I part, is the investment part. Most people want to get to the R part, which is return. Let me use the models, and that's inferencing. And so the world's quickly moving towards inference. And you want to do that as cheaply and as fast as you can, because in the world of tokenomics, it's about how many tokens you can generate in a small amount of time, right? And so we've done an incredible focus on power, performance, and cost so that we can deliver the capabilities at the hardware level at a significant advantage, somewhere in the 5 to 10x performance advantage compared to NVIDIA chips at 1/10 the power. Right, 1/10.
1/10 of the power.
1/10 the power.
That I think is very critical. So tell us a little bit about how to me, power is a big issue.
Right.
Because we need such a big wave of AI need, which means we need a lot of data centers, which means a lot of power.
Right.
So the fact you can run your inferencing applications at 1/10 of power, huge savings of power. So how did you achieve saving of magnitude that you're discussing?
Yeah, and we see this recently. We had the Deepseek announcement, and that stopped the world as far as the achievements, both in terms of kind of what the quality of the model, but how much it cost them to deploy them to train that model. But what they also released was the fact that it took 40 racks of NVIDIA, 320 chips, to inference a single 671 billion parameter model. Right, and so if you look at that, multiplied by the fact that each NVIDIA rack, I think the latest is 140 kilowatts per rack, and you start now seeing, well, how much power it's required to just inference one model. Mm-hmm. SambaNova is running that model today 4 times faster at one rack, 10 kilowatts. So not 40 racks at 100 kilowatts, but one rack at 10 kilowatts. And so this is kind of the orders of magnitude difference that we're able to achieve using a different architecture and using these customized chips that allow you to actually deliver the performance on standard open source models, and gives you the economics, gives you the performance, gives you the power benefits that you just can't achieve using legacy architecture.
Right. So I remember 2017 when I listened to your presentations and this whole idea of data flow architecture, which is really about AI. It's not about just some compute. It's not about doing just matrix. It's about how efficiently you're moving the data.
Right.
And I remember that discussion, and it looks like now, of course, I've been monitoring it.
Yeah.
I'm very proud that the fact you've been achieving the progress like you have. Now you have a full systems that can be able to deploy. They can be able to provide options to many countries that may want independent systems from a large-scale public or private enterprises.
Right, exactly. And I think the world's going to be hybrid. I think countries are seeing this, that they're going to have use cases where they want to use a very large cloud provider alternative, and they're going to have many, many needs, which because of their data privacy concerns, where their sovereignty concerns, where that's IP concerns, they don't want that mixed into a big model where everybody might be able to access that information. And so you're going to have this hybrid environment where those private use cases are going to be extremely important. And in my view, over time, the dominant use case, that over time, companies and governments are going to actually have more and more deployed in different places, because we are running out of data and your private data becomes increasingly more valuable. And so you want to keep it as your own. You don't want to contribute that into a common depot, right? And so as you have more and more value accumulated in the private data, you want to find a way to protect it.
Also, privacy issues.
Yeah.
Also, every country wants to protect their citizens' data.
Right.
So there is certain boundary conditions where data can go.
Right.
And as we know, most of AI service today has been hosted by American large cloud providers.
Right.
And frankly, the whole world want to see more equalized distribute to the world.
Right.
And I think SambaNova is contributing to some of that distribute to the world.
Yeah. No, and it's really important. I think at a sovereign level, you want models that are trained or at least fine-tuned on local data, right? And whether that's local customs, local linguistics, or local policies and laws. And you don't want American rules and American laws, or models that are trained on American rules and American laws being the pervasive model across the world, right? And so you're going to have sovereign countries invest in models that allow you to actually get that level of customization that applies to their region, to their countries, to their regions, and in many cases, companies want to do the same for their own companies.
Right. So, information about your citizens around your national data, it is also their national asset, right? Because data is an asset and enables to keep it within the country and optimize around those. And I think these are some of new reality that are happening, regardless of globalization topics. I think data matters, and data is local. And data need to stay, and this is where I think is an opportunity. Now, let's talk a little bit about how difficult it is actually to build to where we said full stack, all the system levels. But actually, at the end of the day, I've seen how difficult it is to build these systems. So I want to share with the audience what does it take to build your silicon architecture to enable it? And how much it costs even to build these things?
Yeah.
And then the software that requires to build the middlewares.
Right.
And then working with open source LLM to get trained, and then building an API, and then building vertical apps to meet their requirements. If you can give some colors to what your journey has been, that would be great.
Yeah, well, it starts with, we have an architecture that was researched at Stanford, and to commercialize it and to get it to a certain state, certainly it takes a large silicon team. We have a couple hundred people that's focused on chip design, from architecture to RTL to all the way down to, we actually do our physical design as well inside the company, because with our own custom design, we achieve much better power efficiency. And so all of that is really important. And then, of course, you have to license all the tools and EDA tools that are required, and IP, because you need SerDes designs and things like that, right? And so all of that comes into the complexity of designing these high-performance custom chips. But you need them, because before you can do anything on software, you need a substrate that you can actually operate on. And so that's one piece of investment, of which we've now done multiple generations of it, which is the other part that I tell people. If you are committed to being in the chip business, you have to be committed to show up over and over and over again. One time is not enough, right? Because customers are looking for a roadmap. And so that's the piece. The really exciting, challenging piece is, how do I take these models and then, without much manual intervention, try to map it to this architecture? Because ultimately, in the past, one of the biggest challenges we've seen is the porting effort that it takes to move applications from one hardware to another. In this particular case, it's moving models from NVIDIA GPUs over to this. And so by being able to actually have a very sophisticated stack that allows you to take open source models like a Llama 3, or like a Deepseek, or a Quen model, or a Mistral model, any of these open source models, and move them over to the hardware without this huge elaborate effort of people writing manual code like CUDA type style code, I think is a huge win and enabler for the company. And so we've done that.
So, just for embellishing some of your comments, when you look at the silicon enablement, right? The kind of silicon we're talking about is really a small geometry, large footprint transistors. I don't know how many transistors are in your chip. Maybe you can share the latest ones.
I've lost count, because we turn transistors vertical, and then we put multiple transistors per. So I've lost count again. But it's actually, so it's state-of-the-art TSMC fabs using the largest number of metal layers. Then we use CoWoS to put multiple die. So you got multiple large die that need to be cooled with very good cooling interconnect. And then you have these HBMs that are attached on the side with this big package. Then there has to be the whole thing attached on these really high performance boards. And so the amount of engineering that goes into just the physical attachment of these things using state-of-the-art technology that's then burning an incredible amount of power, even as low power as we are, is still a lot of power that we're dissipating in a small amount of area. It's an incredible engineering that's happening, not just from us, but through our partners as well.
Yeah, exactly. So it's an insane amount of engineering that are going on. And we're talking about billions and billions of transistors that are all put it all together. And it just shows the modern electronics does not happen by itself. It happens with a partnership, with the ecosystem you have to work with, and then crank those things out, and it probably costs you $100 million at a time, right? When you put it all together, I would imagine.
Yeah, at least because again, these people who are in the semi space, you have to create masks, and you have buy prototype wafers to test it and make sure it all works, and you have to build systems. And so at least it's that. But look, it's when you actually deliver these types of technologies that differentiate at this level, it's an incredibly stabilizing portion of the business, because you can change the software and the models above it, but the hardware doesn't have to change, right? One example I give people is we're on a 4th generation chip that's in the market that was taped out over a year ago. Deepseek shows up this January, and we're #1 in the world. And so the ability to have this very flexible platform is not customized for any one model.
Right.
New models show up, and you can be #1 in the world. It achieves a level of certainty for customers to know, oh, I have investment protection.
Right. So this also shows that strength of your architecture, because your architecture is flexible enough to take the changes. And also, I think your software team, they can be able to automate those transitions, right? Because I think one of the issues today with the moats that NVIDIA have built was speed, the way they're adding new advanced packaging solutions, as well as the CUDA compatible framework has been a challenge, and overcoming those is not an easy, and it's a big, major project.
Yeah, no, I agree. I think, well, the nice thing about the CUDA moat that has been talked about is for a company like us, the beauty of it is you need 0% CUDA when fine-tuning and inferencing, right? And as the world's moving towards this inferencing, you can download a model from Hugging Face, and with 0 CUDA, you're running it as an inference service in an hour, right? And so I think the world is opening up in this way that allows other architectures come in, where in the pre-training world, it was certainly significantly more difficult because people had invented their pieces in a CUDA ecosystem. And so this has now opened up this opportunity for new players like us to be able to participate.
So this is really talking about the evolution of how things evolved, right? How the NVIDIA kind of led more private approach on CUDA framework. And then, of course, the open source Llama came in from others that enable the now additional architecture that can come in, which give you flexibility and mobility as you're supporting these new approaches, and which give you the silicon flexibility, architectural flexibility, and ability to support the models on the top. So tell me, now we are going from these large language models that are going from billions and trillions now.
Yeah.
Where are we going next? How do you see the whole generative AI going, and how the agentic systems are coming in this space? And how did your customers tell you in terms of their expectations and applications?
I think the two very strong trend lines is, one, I think the models are going to go bigger and bigger, just flat out, because you want robustness in the model. You want models that aren't too brittle, right? If you ask this type of questions, answers correctly, that type of question is wrong. So people are moving towards bigger and bigger models. You saw Llama at 400B and then Deepseek 670B. You're going to achieve 1-2 trillion parameter models. That's one trend line. They're going to be MOE, but it's going to be very large. And then the other trend we're seeing is the agentic systems, as you talked about. I think people are prototyping with 10, 20 agents in a single system that are hands-off, from one agent to another for a particular type of workflow. I think that's nowhere close to the steady state. I think the steady state is going to be thousands and thousands of agents, all interactive in a complex system that you can actually build up over time. And so those two trends are coming in a hurry, right? Because people see the value. You're starting to see that you can start replacing these business workflows by adding very simple and verifiable agents, right? You can see, oh, does this agent do this step very, very well? And can I certify, verify, and can I trust it, right? And so as you do those things, now the businesses are able to then believe that, okay, I trust the agent to do this step, and I can start constructing these workflows that then over time create an immense amount of improvement and efficiency for businesses.
So more general solution to now specific solutions that are verified and validated, and then being able to add those intelligence over time. And then, of course, now people also then talk about the reasoning that are coming after that. So how do you see that as a part of your roadmap?
You see it with Deepseek 671B, which we offer today on our cloud, and it's our most popular model. And to the audience, they haven't tried, they should go in the cloud.sambanova.ai and try it. It's just fantastic. This is things that would have taken us weeks, if not months, to kind of rationalize through, and then you can actually get a very well thought through answer. I give the example that for businesses, people are like, oh, what's this reasoning thing? It's like, well, you can ask a question like, how's my business? Well, the response could be, is it my stock? Is it my revenue? Is it my products? Is it my employees? It could be a number of different things, right? A reasoning model is walking you through all those different steps so that you have a complete picture of a very ambiguous answer. And then you can come back and ask additional questions that further reason. And so this is the value of these models. They're just so good because it's really thinking through a problem in the way that our brains will think about it.
So I think Jensen at the last GTC talked about where is the next step, right?
Yeah.
And then he talked about physical AI,
Yeah.
which to me is like robotics,
Yeah.
autonomous driving,
Yeah.
drones, all that type of stuff that are physical embodiment of the technology that are enabling the applications.
Yeah.
But what is your perspective on that?
I completely agree. I actually think for years I've been drawing the parallels between internet as a technology to the applications that we've used. And so you look at the internet when it started with kind of places like eBay where you had data center use case and you go to the data center and cloud to actually use the internet for a variety of things. Eventually got to cars, got to your toys at home for kids, right? I think AI is going to have the same thing. It's going to permeate and through everything that we do, and it's going to actually have capabilities that we've never seen. And so I do think that the opportunities are abound for these types of edge-related use cases, and it's going to continue to expand. As the edge use cases increase, you're going to actually have even greater demand on the data center side to support either the training of those models and inferencing of those models from remote, or this cascaded view that we have in the internet, which is how do you actually take these models and make sure that they stage them so they can pipe all the way back to the data center.
It's great. Let's talk a little bit about the landscape. And clearly there is a lot of players with a different strategy. NVIDIA clearly took the shot and has done a really good job of pioneering the whole industry, and others following rapidly. But there are different models, right? If you look at folks like cloud players, clearly they are depending on NVIDIA, but they're also looking for independent paths. Right. They're also doing their custom accelerators. Yeah. It's pretty well known that they're working on these things. And then you're working on your solutions. How do you see the whole landscape working out? How do you see in terms of your part of opportunities given the different players in market today?
Yeah, I mean, I think there's a P0, which is, I think the world, and NVIDIA's done a tremendous job, really serving this market, but I think the P0 is the world's still going to look for alternatives to NVIDIA. It's good from an economics perspective, good for us to have choice, right? And so I think that's a P0. Where that comes from the hyperscale cloud providers, or from the model providers, or for other independent technology providers like ourselves, I think time will tell. But here's what, when it comes to alternatives, here's what I focus on. To me, ultimately, I think computing, in a generic sense, is ultimately going to be about providing the best value in terms of performance, privacy, security, at the lowest cost in terms of dollars in acquisition and operational cost, right? And so that's kind of our basic principles: is are we providing the value that solves these needs at the lowest possible cost, right? And over time, I think everybody's going to be evaluated against that, whether it's delivered through a cloud provider or through a non-prem provider or through a service. It doesn't matter. I think end of the day, the economics is going to come down to those three things, which is basically the three things that you value at what cost.
Right. So we talked a lot about tokens per watt, which is really critical capabilities, and looks like you want to differentiate in that angle as well. But at the end of the day, you got the you have to provide service, right? Mm-hmm. So as you're looking at the full stack service you're providing, if you look at your customer base, where do you think your customer would be? Do you think hyperscaler could be customer? Or is it more like a national AI center that could be customer? Yeah. Or is it enterprise private cloud AI center? So tell us a little bit about how you see the market.
Well, I think our market is basically into three segments. You have the cloud consumption folks, a lot of developers, people are on the cloud, and you can use SambaNova Cloud, you can use a partner's cloud. It doesn't matter, but you're doing a consumption type of model, right? And so, there's some amazing companies getting created in this AI cloud ecosystem, right? And we're gonna be players there. Then you're gonna have enterprise customers, and these are the Saudi Aramcos of the world, the banks, people who are using it to improve their own business. And so those who deliver those on-prem or in colos and a cloud, it doesn't matter, but they're the end users for the enterprise. And then finally is the data centers. And this could be hyperscale or regional data centers. They're taking our infrastructure, providing alternatives to their customers in terms of very fast inferencing, very large models, agentic systems. There are things that we do that is today not as easily done on NVIDIA systems that we're able to then provide these customers to then have them offer to their ecosystem.
Great. Let's talk a little bit about your entrepreneur journey.
Yeah.
Like going back to, because clearly, I remember when we were discussing, you were joining from, I think you were at the Oracle at the time, right? Yeah. And prior to that, you were Sun Microsystems.
Yeah.
And had a distinguished career there and leading large number of engineering teams with an excellent record. This is what Lip and I was talking about you behind the back. And then absolutely, when we invest, we look at not only the idea, but also we back CEOs.
Yeah.
And that was really important to us. And I'm so glad that we have backed you and see where you are. But tell us a little bit about your journey. What are some of excitement you had, some of the challenges that you went through?
Yeah, well, I've been in high-performance chip design for 30 years. I started with HP when HP still had a fab in Palo Alto, right? And we built PA RISC processors and the first wave of Titanium processors, and then went to a couple startups, one of which was founded again by Kunle, who's our current co-founder. And he was the father of multi-core in that he created this multi-core startup that I came in and joined and was then acquired by Sun, and became the platform for Sun's hardware strategy. And so, and in that journey, there's a lot that you learn when you actually try to take a company that's small into a big company through an acquisition, and then you're trying to scale that, that idea to hundreds of thousands of chips deployed in the world, millions of chips eventually deployed in the world, and the learning around scaling is just a whole nother thing, right? It's one thing to design something, right? It's something else to find a way to deploy it, from the reliability things that you have to worry about, to the operations of kind of how you manage all the inventory, to all of the deployment and support. I mean, there's just a lot that comes into it. And then from that journey, as Sun was kind of nearing its end, and Oracle acquired it, it became part of Oracle, and I learned so much around how do you create this integrated stack. And the one thing I did learn from that part of it is the value capture. If you're able to go from chips to the solutions, how much value you're able to capture for your business if you finish the product, quote unquote, finish the product, right? And so we've applied so much of that into SambaNova, because otherwise you leave a lot of homework for the customer to do, right? And so we've elevated all the way to the API so that whatever you're already doing as an API to OpenAI or an API to some other service, you can just move it an API into SambaNova, made it easy. And so that's one of the most important learnings I have from my time at Oracle after the acquisition, in that they are just so good at understanding kind of how to capture the value where the customer needs it, so they have time to market, right, ease of use, and then make it seamless for the customer to actually take it and apply it and then generate value.
Right. It's about understanding customers and going all the way for their need, right? So when the Deepseek came out, were you surprised?
It was a surprise to everybody, because for a long time it was the idea that basically the large models were dominated by American technology companies, right? And you saw that whether that's from Google's or the OpenAI's. And then suddenly this company was able to, at least through their papers, show with such an incredibly low cost, train such a high quality model. And they opened it and they showed everybody. And so aside from the fact that you can say, what is the data that was used and all of the things around kind of when globally people are trying to decide, can we use this model and in what ways? What they did do is they showed that there's a much more efficient way for us to deploy these models. And we're seeing it now, right? Why is SambaNova able to generate this type level of performance in such a small fraction of cost and power? Because the model is able to operate on these types of architectures in a completely different way. And as I said, it's MOE, right? And SambaNova is perfect for those MOE architectures. And so now we're able to not just run Deepseek in that way, we can run other MOE models in that way in an incredibly low power and low cost, because Deepseek show people the value of architecting these models in this way.
It was really interesting to see their, the understanding the Deepseek approach. It was nothing like new. Right. It was published in many ways, but they put it all together and practiced it and worked on it. and changed the paradigm a bit here.
Yeah, they did, and I think this is one of those things where it shows necessity kind of breeds innovation. It's they didn't have the infrastructure that they needed to do it, and so they created different ways to do it, and just happened to be perfectly aligned with the composition of experts architecture that SambaNova has, right? MOE can actually host all of these individually, and so we're now benefiting from the fact not only the Deepseek changed the way that people train, but they're actually changing the way that these models are going to be inferenced as well. And so we're super excited about that.
So if you're betting on the winners for the large language models, for instance, how do you see? Do you see OpenAI continue to kind of dominate this race, or do you see some other options that are going to come in?
Well, I think OpenAI has just done such a good job actually leading the way, and you got more users than any other model out there. I think it's hard to beat, right, when you have that much
it's
traction.
It's the scale effect.
Yeah, the scale effect, and they continue to innovate. So that's the important thing. That said, the open source community is doing some really amazing things too, right? Whether that's Deepseek or that's Llama from Meta,
right.
and Mistral, right? People are innovating around it, and the beauty of the open source community is they're all learning on each other, right? And so I do think that the open source community is certainly catching up, and there's a very, very large contingent of companies that continue to invest in it, and I do think it's going to be a big player, especially for entities and countries and companies that want to own their own model, right? You can take the open source model, you can customize it, and that's yours forever. Harder to do if somebody else's private model.
So you can see the world bifurcating into the large model driven by things like OpenAI, but also the local models or the country or government models that are driven around their own open source approach. You see that both sides.
Yeah, I do. I think you're going to have these closed source models that will add certain value. The open source models will give you, large and small, will give you a bunch of other value. And that's actually then cross-section around that's in public clouds or private clouds, right? And so you can see how the landscape will kind of start segmenting in that you may have open source models in private clouds, open source models on AWS, and closed models in clouds or private. And so I do think that it's going to be a hybrid world, right? It's going to be a hybrid world because people want to actually deploy solutions that fit the problem instead of just force-fitting the solution into existing infrastructure.
They want their own options as well.
Exactly.
That makes sense for them,
yeah,
right?
Exactly.
Okay, very good. What are some of concerns you have given where we are with a massive investment and massive wave of opportunities? And as you know, the data is doubling every year, right?
Yeah.
So it is an incredible amount of data that are coming. The more we train, more data is coming.
Right.
So we have to figure out how to manage all those in a cost-effective way with the right power.
Right.
So what are some of the things we should think about when you're architecting some of our solutions going forward? What changes do you see next 5 years?
Well, and it depends on who we're talking about. I do think that companies that are building models and companies that are building solutions should think about interoperability. I think it's not always a blank sheet of paper. I think when we started the AI journey, it was much earlier. Yeah. So everything could be a blank sheet of paper, right? Now we have to start thinking about the fact that, some applications, people have embedded those applications with models that are a couple years old. It might be Llama 3, and we may be over here on Llama 5, right? And so the idea that it's always going to be a blank sheet of paper, I think we have to start thinking about how to create platforms that can leverage things that are in production, that they don't want to change, while integrating new things. So I think that type of kind of interoperability and abstraction is going to be important. I do think that the other thing that I think people we already touched on is at scale people are really, really worried about power, right? More and more. I just got back from Asia and people are out there thinking there is no more power, right?
Yeah.
Right. In some of these countries, it's not like I can go and erect more nuclear power plants or put. People are talking about that, but there in many parts of the world, there is no more option.
It's funny, we used to say in our computer science area, we measure everything based on compute, right?
Yeah.
Flops.
Yeah.
How many, execution can you do per second?
Right.
That was the measurement.
Right.
I think today we're measuring everything based on watt.
Yeah. Yeah.
It's all about power.
Yeah.
And those that has the power has the first mover advantage.
That's right.
And land grab advantage.
Yeah, that's exactly right. And when I go out and talk to customers and people are asking me, well, how much space do I need? They're exactly right. They're how many megawatts do you need? Which is a really, really interesting dynamic in just a very short number of years, right? In a short number of years now, everybody's thinking about megawatts and gigawatts in terms of data center. But there's three pieces to that challenge that I think we all have to think about. One is the fact that you have to supply the power, right? And this is something that we just don't, we need to figure out where the power comes from. Is it nuclear power plants and no solar power plants? Where's it coming from? Two, we have to figure out how to cool it, right? The cooling of it is very, we're already using liquid, and we're trying to do all sorts of very sophisticated cooling techniques because we've got to cool it and still have kind of the sustainability challenges that we have already. And the third part, which I think we're starting to realize, is between the power source and the data center, we need to figure out how to distribute that power. We're in some places doubling the total power consumption in the city. So how do we get the power distributed over properly? And so that distribution is always challenging. So the entire area on energy tied to data centers is a very, very big challenge for us. And so we have to solve in multiple ways. SambaNova, our first step is try to deliver more with less, right? Yeah. Start there. It doesn't necessarily say that we aren't going to need more power, because I do think, but at least slows things down to allow the rest of our technologies to actually catch up. Because nuclear power plants are hard to create, and other power energy sources are hard to create, and so we need to buy ourselves more time.
Yeah, I think that is the global challenge. I think scaling and compute is much easier than scaling power overnight, given the limited resource, the limitation of the the sustainable energy. Right. And the location and the implication of distributing this power has an incredible challenge for, I think, our community. And what you're working on and providing a tokens per watt that are much more efficient than the leading players like NVIDIA would be a very good option to and on the top of the providing alternative options to a lot of players that are needing to have independence.
Yeah, well, and we've been handed a gift. This is the gift I tell people. The world's moving towards inference. That's going to be, in the next couple of years, 80% of the demand. And for that 80% of racks, we now have technology like SambaNova that gives you 10x the performance and 1/10 the power. Right. So you can actually take what's going to be the largest part of demand and collapse that footprint, and can reuse that racks for other things, right? And so we've been given a gift that the demand is shifting to inference, for which we have new technology can actually significantly, orders of magnitude, reduce the power required to deliver the same throughput. And so there are things that that we can do while we solve the broader problem. How do we actually deal with energy?
As Deepseek has shown that it can actually do over, right? 95% less power efficiency than the traditional NVIDIA based models.
Exactly. And with that time, all the innovation around better performance and much lower power, I think you're going to see more and more solutions come in.
Excellent. Let's talk a little bit about also your team. Yeah. The culture and how do you manage to grow and try to motivate your teams here?
Well, we've come with phases of the company. When we started the company, I've been so blessed with all these incredibly experienced people that just believed in the journey and believed in the leadership. And at one point, 80% of the team here have worked for me for 15 years or more. And so the team that's been working together for a long time, and that's why we're able to build chips and systems so quickly. As the company's evolved to now, really happy about kind of the new team that we've kind of brought in as the company has grown, because now we're into a lot of the go-to-market activities and the operations and being able to serve clouds, and we've been able to bring some of the best people that understand those segments well and really blend it with the existing team. And so it's been a journey for us in trying to kind of grow as the company is growing and changing the needs. But one thing I've just always been proud here is we've been able to attract and bring in some of the most amazing people in the industry. I mean, if you on their own, you look at their resumes, I mean, they're like some of the top people across all of the, who's who in our tech industry, right? And so it's just And for something like this, you need just incredible people. I can't do it by myself, you know, and you need amazing people that understands, you know, kind of what needs to be done and have it self-run, you know. And as much as I travel these days, you know, the company kind of self-runs because we have an incredible leadership staff and a team that just knows what needs to get done.
Right. You know, I think that I remember Lip-Bu and I were thinking about investing in SambaNova concept we're developing. It was about the team.
Yeah.
It wasn't about, you know, obviously we need a strong leader like you did, but you also brought the team.
Yeah.
And that combination accelerate the deployment and development of companies like you are doing.
Yeah, I mean, and the results speak for themselves. And again, I'm always incredibly appreciative of investors like yourself and Lip-Bu who just have the foresight. I mean, I remember, forget what number I asked for, but I asked for a large number. But I said at the time, yeah, this is going to be an expensive endeavor because we're going full stack. But 7 years later, we've taped out 6 chips. We've got 4 generations on the market. We're 10x faster than NVIDIA at 1/10 the power. So some of the ability, you know, what we've been able to show with a team that knows what they're doing is starting to come into fruition, and that's what's exciting.
Yeah, you know, they say investing in deep tech is not a faint heart, right? It requires a long-term thinking, patience in mind, and need a good partners to back up great entrepreneurs.
Yeah, you do, because it's never a straight line, right? And certainly in this, you know, in the last 6-7 years, it has not been a straight line.
Oh my
right?
God.
You know, it's just every other day there's somebody that invents something amazing that disrupts the entire tech market, right? And so, but being able to continuously innovate around that while you're in this hurricane of technology, right? It's been something that I'm just really proud of the team, and sometimes it feels like, oh, you know, can we keep up with everything? And somehow you take a step back 7 years later, you're in the market, you're number one across a broad range of things, and leaning into exactly where the trend lines are going, with the models going bigger, right? People worrying about power, people worrying about privacy, and these are all things that I think we at SambaNova has spent 7 years really focusing on.
Rodrigo, I think both Lip and I were really, really delighted that we can be able to sit in the front seat and watch one of the most massive transformations that are happening in our industry. And SambaNova is a great showcase for opportunity to see that. So thank you.
Oh no, thank you. It's been such a great journey, and to have mentors like yourself and Lip-Bu kind of help us through our journey has just been an incredible privilege, and really appreciate all your support.
Keep looking forward to seeing SambaNova growing. Thank you.
No, thank you.
Thanks for joining us.
All right, thank you.